Hey, I'm back for the penultimate time. Again, same cast of characters, and this time, in case it's not clear from the title, I'm going to be talking about SYCL events and what they can do and issues we've discovered in their use and design. So, everyone says AI is taking over, so I thought, I should try to put AI to good use and have it help me design this presentation. So I used several of the different AI copilot generator thingies to try to generate some clip art for this presentation. And I'd say the results were mixed. It's kind of impressive that when you literally give it the text you want to appear in an image, you get this. Yeah. Yeah, yeah. The prompt for this, if anyone was curious, was, please generate a picture of a cartoon newscaster saying, "I, for one, welcome our new event overlords." Yeah, so in this talk, we'll cover several things. We'll start with a brief overview of how dependencies are declared inside SYCL. And then from there, we'll talk about SYCL events, what they are and how they're used. After that, we'll delve into kind of the dark side of events, the hidden costs that we've discovered that appear as your applications tend to get larger and more complicated. And from that, we'll move into some proposed ideas to try to fix some of these problems and then wrap up. So in SYCL, there's really two ways you can think about dependencies in your programs. The first is you can have a data-centric approach. And this is most commonly used when you're using the buffer accessor model in SYCL. So for this example, we have a bunch of different kernels, and we have a couple buffers, A and B. And let's just declare all these kernels and look at the DAG that we kind of get as a result of this. So we submit kernel 1. It's going to produce some data inside buffer A. Then we're going to submit kernel 2. It's going to take that data the kernel 1 produced and make some modifications to it. Then kernel 3 comes along. It's unrelated to the buffer A at all. It's going to shove some data in buffer B. And then finally, kernel 4 is going to read in A and B and produce some new stuff in B. So we wind up getting a DAG that looks kind of like this. And you can specify this with the use of buffers and accessors. And because the accessors, when you declare them, you say which data you're using and how you're going to use it. So in the SYCL 2020 form of accessors, you just declare an accessor object. And if you don't say anything, the default is read write, because that's usually the most common case. Yeah, so for a bunch of these, it's read write. And because we submit kernel 2 after kernel 1, and they're both operating on A, that would be a read after write or a write after write dependence. So we have to enforce that. So that those get ordered. Kernel 3, completely independent, so it could run concurrently or not, depending on your hardware. And then kernel 4, we say we're going to only read A, but we're going to rewrite B. So buffers and accessors, data dependence. And if you've taken parallel programming class, you probably saw the second one coming. So the other way you could think about it is not in terms of the data you're dealing with, but just in terms of the tasks themselves. So you could choose to describe your dependencies by just kind of describing this graph directly, saying I've got 4 kernels. Kernel 1 has to happen before kernel 2, and kernel 4 has to happen after kernel 2 and kernel 3. And this mode often gets used if your program is using pointers or USM. And since you don't have the buffers and accessors anymore giving you this information, you need to specify these edges in your DAG some other way. And in SYCL, we do that through the use of the event objects that were always there, that are always returned whenever you submit a command into a queue. And then we can explicitly declare dependencies using those. So in order to express this, we can get event E1 back from submitting kernel 1. And then when we submit kernel 2, we can say that kernel 2 depends on that event from kernel 1 and generates event 2. Kernel 3 doesn't depend on anybody, so we don't see it depends on there, but it's going to produce event 3. And then kernel 4 is going to depend on event 2 and event 3. So events happen to be this nice thing. They were already in SYCL. We didn't have to add anything to SYCL to support this and to support a nice way of declaring dependencies with USM. So that seemed really great. So SYCL events really proved themselves to be this incredibly useful hammer of synchronization and utility. And it happened to be this way because every command you submit to a queue returns an event in SYCL. And if you were doing USM programming in out-of-order queues, which are the default in SYCL, it was great. You just use these events and your job's done. But events also did more than that. You could use events to basically query the status of all the commands you submit. Is it in the submitted state? Has it completed? You can use them to explicitly wait on things. But then they were also used for even more things. SYCL has various capabilities for profiling, and all the profiling info was provided via events. So if these things were so useful, what's the problem? Why am I up here? And the answer to that is that nothing's ever free. This was probably the best one. This was generated a motivational poster of a scenic mountain valley that says nothing is ever free. Yeah. Or to say this another way, you pay for what you get. And event creation has a cost. Creating all these events isn't free. And in some implementations, the backend event is always created. And in many cases, these events are never used, or they're just even immediately destroyed. And use cases where that could be include if you're using an in-order queue, which has this inherent synchronization mechanism, or if you're not using multiple queues and you don't have to express any kind of cross-queue synchronizations, you may never even need to use these things. Yeah, and then the event profiling mechanism is basically an all or none thing. Profiling is enabled via a property at queue creation, and it's enabled for all commands in the queue, whether you wanted to profile everything or not. Yeah, and in our experience, we've also found that the in-order queue case can be particularly important, particularly for codes that are being migrated into SYCL from other programming models, because most other GPU programming models, the default behavior isn't an out-of-order queue, it's an in-order queue. And if you're trying to preserve semantics that may be kind of implicitly there in those types of programs, it's often better to map that to an in-order queue in SYCL. Okay, so let's get into a little more detail about some of these things. So the event profiling, like I just said, it's enabled via a queue property. So that means whenever you create the queue, you have to pass this property in saying, I want event profiling in this queue. And one of the consequences or unfortunate things about this is that it can't be toggled on and off later. Like you make this decision when you create the queue and you're stuck with it for the lifetime of that queue. And this is effective and it works, but for a lot of applications, we're finding it's really too coarse-grained. Sometimes you only want to do profiling under certain conditions, like maybe you passed an environment variable in your program. Sometimes it's really only parts of the application you want to profile, or you may have profiling for different sections in different cases. You may want the ability to toggle it off and on. And similar to the in-order queue situation, if you're migrating code from CUDA or HIP into SYCL, you can wind up with a semantic mismatch because that isn't how this works in those models at all. So we can ask ourselves, we've been aware of these problems for a little while, and people have thought about it, trying to figure out if there's anything we can do to improve the situation. And there's a couple existing extensions to try to deal with unwanted events that have been done so far. In DP++, we have one that's called discard events. And that's another property on a queue that says, don't really create events. Like they'll still be there, but we won't create the underlying back-end event. So we don't pay that cost. But that has several complications and some unfortunate side effects as well. The other alternative was a bit more sound. It couldn't result in your program crashing in unanticipated ways. And that was Axel's coarse-grained events extension, where he added this property to try to kind of optimize the behavior of these events with the assumption that in the default case, you're not going to try to do the complicated things. But if you actually do try to do the complicated things, he'll insert the right cleanup code to make sure everything works properly. So great, we got 2 extensions, job done. Didn't we fix it? Unfortunately, in my opinion at least, neither of these solutions is completely ideal. The discard event solution in DPC++ isn't great because it potentially leaves these kind of like ticking time bombs in your code. The events are still there, and if you try to do anything with them, it's going to be a bad result. Your program's probably going to crash. And that was really because that extension was just a quick and dirty thing. We didn't spend a lot of time trying to think of something more elegant like Axel did. But even Axel's solution, it requires the programmer to do more work. You have to add some extra annotations to things, and this isn't necessarily ideal because in large applications, the annotations may wind up being completely separate from kind of the use in some sense. Like you may declare your queues over here in one file or in some other completely different piece of code, and you're writing your kernels over here, and you may not be aware that your queues were created with event profiling or discard events or these coarse-grained events. So it's kind of harder for application writers to reason about what the code's actually doing and how it acts. So both of these solutions are really telling you to do more to get less. And that seems kind of counterintuitive. It seems like there ought to be a simpler, cleaner way to get the behavior you actually want. So of course the solution is more extensions. You know, why stop with 1 when you can have 2 or 3 or 4? Yeah, no, that was just XKCD 927. There's luckily one for just about everything by now. And for people that disagree, see XKCD 386. Yeah. So the gist of what we want to try to accomplish is that we think complexity really should be an opt-in thing. In some sense, if we look back at the history of SYCL and the way it was designed, I think it made some mistakes. In particular, this notion of events by default seems like it was the wrong choice. And it's kind of confusing why that choice was made in the first place, because SYCL 1.2 and 1.2.1 was meant to be really closely tied to OpenCL 1.2. And in OpenCL, events are optional. So it's unclear why SYCL chose to make them mandatory. Similarly, for event profiling, the way it was done in SYCL, I think, was just too coarse and too inflexible. So it's time to fix our technical debt. We need to come up with a cleaner solution. And sometimes Gemini gets the text right, sometimes it doesn't. So those who forget the past are doomed to repeat it. So how can we improve things? So we have this new extension that basically introduces some new in-queue functions, because the best way to eliminate events is to just never have them in the first place. So we have this new extension, one API in-queue functions, that basically just introduces 2 new APIs, which is a new free function way of submitting things to a queue. So instead of a member function on the queue, this is just a freestanding function in a SYCL namespace that takes a queue. And we have submit and submit with event, or named to be potentially bike shed later. But the key point here is the first one just submit, has a void return type. It doesn't return an event. So if you use that, you don't get an event, and you're programmatically saying so. So if you do want an event, just tell us, call the second function, and then you get an event back. We think that's a nice, clean solution that gives you exactly what you want. You only get the events if you actually want them. So that's the events by default. What about some of these other issues, like profiling? So for profiling, we have another proposed extension called profiling tags. And the idea behind profiling tags is we wanted to let the user decide what to profile when. So this introduces one new API that works roughly as follows. So for out-of-order queues, when you submit this profiling tag, it basically synchronizes using a barrier that's used as a marker. And if you're doing this on an in-order queue, it basically just enqueues a marker. It just gives me the next point in the queue. And we have a very simple example here of what this looks like. So we submit two profiling tags, kind of one at the start of a bunch of kernel submissions and one at the end. And we call the first one start, the second one end, submit a bunch of kernels in between. And then we can compute the elapsed time between these two things and call it a day. And this tends to work much more similarly to other GPU programming models. And it's only profiling the things we tell it to profile. So we're not paying the overhead of having to track all this information on every submission. It's only when we explicitly ask the queue to give it to us. We've implemented this currently, and it works if you're using the level 0 or CUDA backends. And we'd like it to work on an OpenCL backend, but we need to design an OpenCL extension to support this first. Yeah. So wrapping up, events have always been part of SYCL, and they're an incredibly powerful part of it. They've been a great tool for synchronization and measurement, but we do think their current design has a few drawbacks. So we proposed a few extensions that we think improve this. The new enqueue functions we think are a very nice way to kind of specify exactly what you want and only get what you want and only pay for what you want. And we think this is also a base for several other features down the road as well. We think this can be, for example, a way to potentially try to integrate with the sender-receiver model coming in C++, because instead of a queue, you could put like a sender and receiver there potentially, and you have very similar syntax without having to change SYCL too much. And then profiling tags, we think, is a better way of doing event profiling to only measure what you actually care about. So to summarize, we pay for what you use, not what you don't. So that's all I have. I'll have the kind of a couple plugs here. We have our implementation online. Please check it out. We have all these extensions there, our implementations. We're happy to get comments and feedback. We got our product versions as well if you don't like the GitHub version. And I'll also give a plug for, we're trying to upstream SYCL support into Clang itself. So if anyone's interested in either participating or commenting on the design, please keep an eye out for pull requests and RFCs and the like. Thank you.
Thank you for that. Thank you for showcasing the problem. I think everybody agrees that, and we show it, for example, on this poster on a lot of presentations, that the latencies of submission are really high in SYCL sometime, and it is because of the events that you need to create. So indeed, we need to have a way of not creating events. This seems to be mandatory. Regarding the API, Intel shows their API. I think I have a different idea on the API. And I think what we want is maybe a little more feedback from the community. What do you think is good? What do you think is not great? How you present, if you are okay, for example, to have a new function name, or you will maybe prefer something more like a C where you create an event and you pass a pointer to this event. So for example, if you pass a null pointer, you have no problem. So maybe for your code, it's kind of more flexible to just if def or if conditionally creating the event, or maybe it's easier than to conditionally change the submit and submit with event. And I think how can I say? The fact that we have too much latency, it's a fact. So we need to solve it. How we solve it now is different API choice. And I think it's very hard to design a good API. So it would be nice if you can give some feedback and something like that.
Yeah,
Which is my first preference.
I'll second what Tomas is saying. And one other thing I'll add is that one of the considerations we had in our proposed design here is that we definitely wanted to avoid breaking backward compatibility. For better or worse, SYCL's shipping today with those APIs that return events and code. There's a lot of code written that expect to use that, and we don't want to break any of that. So our approach that we propose is we think it's just cleaner to add a new API rather than try to alter an existing. Yeah, we spent a long time thinking about is there a way we can do like crazy things with C++ to make, alter the return type in certain circumstances, but we couldn't think of a way to do that just wouldn't break compatibility.
So my second point is maybe for the profiling info, if you go back to the CUDA putting an event after. And so one issue I have with this kind of thing is you are at the mercy of the scheduling, right? Let's say I have another thread or another MPI rank or something else we're running at the same time. I'm really not sure that my event will be on queue, but then another kernel from somebody else can run. So that means I will never get the time spent from my actual parallel for, right? It will be something between some context switching and something like that. So I think it is maybe as you say, it's more, this thing is more or less a timer, right? It's a STD chrono that you put, so.
Yeah, you can think of it as an enqueued timer.
Yeah, so I think now you have some semantic difference. I think it's still valid, but maybe we should be careful because I got beaten by that, for example, in CUDA, where you have some information and they're really wrong. So just something to think about.
Your concern is good, although I'm not sure what we can do about that.